Hello everyone. In this video, let us see some problems on binomial distribution. So earlier we have seen the definition of binomial distribution, which is nothing but writing the PMF, that is probability mass function, and then we have found the MGF, that is moment generating function, and hence we have found the mean and variance of that binomial distribution using that MGF. So here we will be seeing some problems. So let us see the first question. Check whether the given data follows a binomial distribution or not. So two data has been given, mean value is 3 and variance value is 4. So we have to check whether this mean 3 and variance 4 will hold for any binomial distribution with parameters n and p. We already know that the mean value of our binomial distribution is np and variance of our binomial distribution is NPQ. So ultimately what they have given us, this mean value is 3 and this NPQ value is 4. So we know that NP is 3 and NPQ is 4. Now let us substitute this NP value here. So Q will be 4 by NP. We can write it as Q is equal to 4 divided by 3, and if we calculate the value of 4 by 3, it is 1.333 etc. And we know that Q is nothing but the probability of failure. See, if P is probability of success, then ultimately Q will be the probability of failure. And always a property of probability is there, that is P of A. Probability of any event should lie between 0 and 1. It should not exceed 1. But here, based on the given data, it is easy to obtain that Q value is 1.33 something. But the range of P should be between 0 and 1. But here we are getting Q is 1.33. Then our P value will be minus 0.33 etc. So that's what given here. Both the condition we can take. So these two values cannot be the mean and variance of binomial distribution respectively. That is our conclusion for this problem. Let us go to next problem. The mean and variance of a binomially distributed random variable Ex are given as it is E of x is 8 and variance is 6. Now we have to find probability of x greater than or equal to 2. So what we are doing is E of x, it is taken as NP, variance of x is taken as NPQ. So we can write NP is 8, NPQ is 6. Q can be written as 6 divided by NP, which will be 6 by 8. Or in other words, we can write Q is 3 by 4. If Q is 3 by 4, then P value will be 1 by 4. So P, we know that value. And for binomial distribution, to write the PMF, we must know two parameters, that is N and P. So P value we know that. How to find that N value? We know that mean, that is E of x. NP is nothing but 8 and I am able to find that the value of P is 1 by 4. So substituting that P value here, I am able to get N value as 32. So N is 32 and P value is 1 by 4. So our binomial distribution is nothing but, that is x follows binomial distribution with parameters 32 and 1 by 4. So here we can see that the PMF of binomial distribution is, I am writing it as probability of x is equal to k 32, or you can write it as x is equal to x 32 cx 1 p power x and q power n minus x. So this x varies from 0 to n and n value is clearly 32 here. Now the question is, we are going to find probability of x greater than or equal to 2, and one more thing, if we are finding probability of x greater than or equal to 2, note that we have to do x is equal to 2 less probability of x is equal to 3 less probability of x is equal to 4 up to the last n value, which is x is equal to 32, which will be a very tedious process. So what we are going to do is subtracting probability of x less than 2 with 1, because we know that the total probability will be 1. We can use this property, and x less than 2 we are having only two values, which is x is equal to 0 and x is equal to 1. So substituting the value of x equal to 0 correspondingly and x is equal to 1 correspondingly, and taking the term 3 by 4 whole power 31 commonly outside, using calculator you will be able to obtain the value 0.9988. So the main one in this question is using this property. Next one, this problem is a very standard question in binomial distribution. Okay, so 6 dice are thrown 729 times. So we have to understand the question clearly. So totally 6 dice are thrown. Okay, and these are thrown for 729 times. So the question is asked how many times. So among this 729 we have to find the probability. How many represents the probability? Do you expect at least thrice or at least 3 dice to show 5 or 6? So among 729 times we are going to find how many times we can expect at least 3 dice to show 5 or 6. So what we are going to do is we are going to find the probability of success, that is P, and probability of failure, that is Q. Probability of success is nothing but getting 5 or 6, minimum of 3 dice. Okay, so minimum of 3 dice means that follows our binomial distribution, because the total count is 6. 6 dice are there, and if we are able to get 5 or 6 in minimum of 3 dice among 6, then we will be able to count that throw as a success. So first we are going to calculate what is p value, that is probability of getting success. So getting 5 or 6, it will be 2 by 6, 1 by 3, and probability of not getting 5 or 6 will be 1 minus 1 by 3, which will be 2 by 3. Okay, so x follows a binomial distribution with parameter n is equal to 6 and p is equal to 1 by 3. So here we are writing the PMF of binomial distribution. Probability of x is equal to x is nothing but 6cx, 1 by 3 the whole power x, 2 by 3 the whole power 6 minus x, where x varies from 0, 1, 2, 3, etc. up to 6. Now the question is, at least thrice means the value should be greater than or equal to 3. So in 3 throws we can get in 3 dice or 4 dice or 5 dice or 6 dice. So this is nothing but probability of x is equal to 3 plus p of x is equal to 4 plus p of x is equal to 5 plus p of x is equal to 6. So instead of adding these four values, what we are going to do is we are subtracting p of x less than 3 from the total probability 1, because finding the probability of x equal to 0 and x equal to 1 will be easy. So rather than finding the probability of larger numbers. So up to 2 we are going to do that. We can take 2 by 3 the whole power 4 commonly outside. So using calculator we will be getting 0.3196 as our answer. So this is the probability of getting success in one throw. But the number of times the experiment is repeated is 729. So we are going to multiply the 729 with our probability of success in one experiment, so that we will be getting our total answer as 232 times. So among 729, at least 232 times we will be able to get 5 or 6 in minimum of 3 dices. So that's the question. We have to understand the difference between 729 and 6 in this problem. That's why this is very important question in binomial distribution. And see this question. The probability of a man hitting the target in a single shot is 1 by 4. If he fires 7 times, the probability that he hits the target at least twice. How many times must he fire? So how many times means they are asking n value. So that the probability of this hitting the target at least once is greater than 2 by 3. It is at least once is greater than 2 by 3. So we are going to write the binomial distribution. Clearly he is throwing, I mean, he's hitting, the number of chances is 7 and the probability of hitting the shot is 1 by 4. So, probability of x equal to x will be 7cx 1 by 4 power x 3 by 4 the whole power 7 minus x. X values from 0, 1, 2 etc. up to 7. And note that if p value is 1 by 4, then we can write the q value as 1 minus p, which is 1 minus 1 by 4, which will be equal to 3 by 4. Okay. And next one, probability of hitting the target at least twice means it is greater than or equal to 2, and we are going to add the value starting from 2 up to 7. So which will be very big. So we are going to use the property 1 minus p of x less than 2. So we are going to take x equal to 0, x is equal to 1, similar value 3 by 4 the whole power 6 will be taken commonly outside, and using calculator we will be able to get the value 0.5551. And second one, let n be the number of times he fires. We are going to determine this n value, and the probability of hitting the target at least once is greater than 2 by 3. So probability of at least one hit will be greater than 2 by 3. So we have converted this wording into our statement. At least one hit means we can write it as probability of x greater than or equal to 1. So instead of writing x greater than or equal to 1, this can be written as 1 minus p of x is equal to 0. P of x is equal to 0 is nothing but, note that here we should not write 760, okay, because here we are finding the value of n. We are not assuming 7 times only he is throwing the uh, he is throwing to hit the target. Here we are going to find the number of times he can throw, so that the probability of hitting the target will be greater than. So we are going to determine the value of n. So we have to keep it as it is. So n will be as it is. So we will get 1 minus 3 by 4 the whole power n is 2 by 3. We can bring that 2 by 3 this side. So 1 minus 2 by 3 will be 3 by 4 the whole power n. So this can be written as 1 by 3. By trial and error method, we can find, suppose this right hand side value is 0.333 something. So if 3 by 4, if you put n equal to 1, we will be getting 3 by 4. 3 by 4 is clearly 0.75. This is not equal, and if we put like that up to n is equal to 3 itself, this inequality will not hold. So the minimum value when this inequality holds is n is equal to 4. Next one, this is a very simple question. If 10 screws 10%, here instead of giving the value straight away, they are giving the probability as percentage. Screws produced by an automatic machine are defective. Find the probability that out of 20 screws, the number of screws is 20. We are going to find exactly 2 defective, at most 3 defective, and at least 2 defective, between 1 and 3 defective inclusive. So clearly it is given as n is equal to 20, and p value is 10% means we can write it as 10 by 100, which will be equal to 1 by 10, and q value will be, clearly it is 9 by 10, or we can write it this as 0.1, or this can be written as 0.9. For calculation purpose, it is easy to keep the fraction as it is. So first one, we are going to write the PMF function. X varies from 0 to 20. Exactly 2 screws. Substitute x is equal to 2. Straight away we can get the answer. Next one, at most 3 means the largest value itself 3. So x should be less than or equal to 3. We can take 0, 1, 2, 3. Substituting the values, we will be getting 4 terms. Here The minimum term is 9 by 10 the whole power 17. So I'm going to take it outside, writing the remaining terms and taking the terms commonly outside. We'll be able to get the value 0.8670. And next one, at least two screws is given. So it can be 2 or more than 2. So x can be greater than or equal to 2. So you can write this as 1 minus p of x less than 2. So it is x is equal to 0 and x is equal to 1. This simplification process will be easy. We can take 9 by 10 the whole power 19 outside. So finally we will be getting the answer 0.6083. Last one, probability between 1 and 3 defective screws inclusive. The word inclusive is given. If it is inclusive, then we can write equal to symbol, that is 1 less than or equal to x less than or equal to 3. So we are going to add 1, 2 and 3. So there are 3 terms and the common one is 9 by 10 the whole power 17. We can take it outside. This will be the remaining term, and using calculator we can get the value 0.7455. Thank you.